All right, so the next question is, this is 10B part 2. The next question is, perhaps you've heard that if you dig a straight hole from the United States through the center of the earth, you'd come out in China. Is this true? So let's go back to the video here, or not the video, but let's look at our little earth here. So if we are right here in the United States, right? And then all of a sudden we end up heading straight through the center of the earth. We're going to end up in the southern hemisphere, aren't we? And China is not in the southern hemisphere. It's also in the north hemisphere. So that's absolutely not true, is it? So anyway, then no, that can't happen. And then let's see. Whoops, I like to keep that up for our next question. Let's go back to our notes. So this is no. China is also in the northern hemisphere. You would end up in the southern. Hemisphere. All right. Now it says, suppose you travel 1 degree of latitude north or south, how far have you actually traveled? The circumference of the earth is about 25,000 miles. So if we are just traveling 1 degree of latitude north, so wherever we are, if we move up 1 degree of latitude north, then your circumference is going to is 25,000 miles. So if the circumference is 25,000 miles, then you're going to be traveling the same distance for every degree that you move. And if I travel 1 degree north for that distance, 25,000 is the actual circumference, I'm going to be going 1 degree of 360 degrees movement. So 1 of 360 degrees. So we want to find out what of the circumference, 25,000 miles, how many miles is that? Well, our degrees divide away, and we're going to end up with whatever 25,000 divided by 360 is. And that is 69.4. We better do an about. Miles. So basically, you're going to be traveling about 70 miles for every degree that you move in latitude. All right. The next couple of questions says, find the latitude and longitude of the location on Earth precisely opposite of a town located at latitude 41 degrees south and longitude 117 degrees east. So first of all, the 41 degrees south, remember wherever you are, so here's this. You are at 41 degrees south, so you've gone that distance south, 41 degrees south. So you're going to pop out on the other side the exact same 41 degrees, but in the northern hemisphere, the same exact distance from the equator coming around here up north over there. So as you move around 180 degrees, you're going to end up in the other hemisphere, but the same latitude, 41 degrees. Now with the longitude, as you recall, and then if you're in, let's see, you're in the eastern right here, you're moving in the eastern, you're going to go around, you're going to end up on the west side, whatever the difference of 180 and 117 degrees is. So 180 minus 117 is 63 degrees. And so you'll be 63 degrees on the west, in the western west, okay? So which is the farther from the North Pole, Sydney, Australia, with a latitude of 33.86 degrees south, or Harare, Zimbabwe, with a latitude of 17.86 degrees south? So farther from the North Pole. These are in the southern hemisphere, both of them. So the one with the farthest distance from the equator will be the farthest from the South Pole, because it's moving at a latitude that's downward more south than this one. So it's obviously Sydney, Australia, isn't it? All right. I believe that has everything to do with our latitude and longitude questions. And next we'll be moving on to angular size and distance. All right, let me grab my PowerPoint back because it's pretty cool. I need the pictures. Okay, if you hold a coin in front of one eye. All right, now I'd like to show you what this means, or kind of, I don't know if you can see this. So imagine I'm looking at this coin. If I hold this coin in the front of one eye, so it's going to block my entire field of view. Right? If I close one eye and I look, there's going to be a part out here that's blocked that I cannot see. But as you move it, so right here with this eye closed, I'm not seeing a whole lot, just the outer edges away from the coin. But if I move this farther and farther away, all of a sudden I see more around the coin and it's blocking less. Now, the true size of the coin does not change. The coin's the same either way, but instead what changes is its angular size. So the angular size means how much angle of my viewpoint am I actually unable to see, and that's what you see in this picture of right here. All right, it's the angle that's covered or seen from my eye. So the farther away an object is located from you, the smaller piece of side or part of your side is going to be blocked, right? Or the smaller it will appear in angular size also. The angle that covers as seen from your eye. So here you go. Here's your eye. If you move the coin out this far, then this is your angular size. And then here, if you move it out farther, this is your angular size and becomes smaller and smaller as it moves farther away. This is another picture. Angular size is the size here. Physical size is the actual size of whatever it is that's blocking in the distance. So as long as the angular size is small, we can think of the coin's physical size as a small piece of a circle. So if you look at this, this is this part of the circle as opposed to this part of its circle. All right, so we have a formula that we can use to figure out angular size. And remember that the angular size is this angle here. It's going to be in degrees. And it's going to be equal to the actual physical size of the item times 360 degrees, so the full circle, divided by the circumference, 2 pi times the distance. Usually that's measured in diameter of the thing that's blocking your view. So we're going to use this formula and answer a few questions. So using this formula for some examples. A quarter is about 1 inch in diameter. Approximately how big will it look in angular size if you hold it 1 yard or 36 inches from your eye? Now be careful with these because 1 inch in diameter, 36 inches from your eye. You're going to use the 36 inches, not the yard, because you have to keep your units in the same measurement in all parts of your equation. So what is this? What is 1 inch in diameter? So when you look up here, 1 inch diameter is going to be the physical size, isn't it? So 1 inch in diameter is your physical size. And then 36 inches is your distance, isn't it, from your eye? So what you're looking for, it says how big will it look in angular size? That's your question. That's what you're actually going to answer, right? So it's your angular size is equal to your physical size, which is 1 inch times 360 degrees divided by 2 pi times 36 inches. All right. Now, I put in all of our little units so that you can see what happens here. Notice that your degree is here. You have 1 inch divided by 36 inches. Well, that 1 inch and 36, and the inch part of 36 inches actually divide out, and you're left with an answer that is 360 degrees over 2 pi times 36. So your answer in angular size is going to be something that is in degrees, right? Because your inches divide out. All right, so 360 in our calculator, 360. Ooh, I'm going to put in a little fraction. 360 divided by 2 pi 36. And that is going to be 1.59 degrees. So about 1.6 degrees. If you hold it, which is very difficult, if it's 36 inches, your arm's definitely, I don't know, Might be, mine's not. But 36 inches away from your eye, you're going to have an angular size of 1.6 about degrees. All right. Now, the angular diameter of the moon, so again, this is angular diameter, is the angle size, is seen from Earth is approximately 0.5 degrees. So that's your angular size. The moon is approximately 380 kilometers from the Earth. That's going to be your distance. What is the real diameter of the moon? So now you're looking for physical size, aren't you? The real diameter is physical size. Now, you can do one of two things. You can solve your formula for physical size. Let's just do that. All right, so if I'm solving for physical size, the first thing that's happening is it's being multiplied by 360 and divided by 2 pi times distance. So what I want to do is I want to times by the reciprocal over 360 degrees. Because if I multiply by that, I end up with just physical size is equal to, on this side, and I have to multiply both sides by the same thing, of course, 2 pi times your distance divided by 360 degrees times your angular size is going to be equal to your physical size if you solve. And that's probably the easiest way to go. So my new formula is going to be your physical size is equal to your angular size, which is 0.5 degrees, times 2 pi times your distance, 380,000 kilometers, divided by 360 degrees. And this is going to be your physical size. All right, now notice this time the degrees divide away and you're left with, did I put it in? Nope, I didn't, kilometers. All right. Okay, so what goes across the top is 0.5 times 2 pi, 380,000, all over 360. And of course, we plug it into the calculator just like that. Now, I'm just going to clear everything out and just make myself a little fraction. Do 0.5, parenthesis 2 pi, 380,000, divided by 360. Oh, I forgot my little parenthesis. All right, and that is going to be 3,316.13 in kilometers. All right, so those are two different types of problems. The first one, you're trying to figure out what your angular size is, and the second one, you're looking for the physical size. Okay, one more problem. A planet has an angular diameter of about 0.1 degrees and a distance. So you have your angular diameter, angular size, and your distance is 133 million kilometers. What is its true diameter? So true diameter, again, is going to be your physical size. So we're going to use the same formula that we figured out here. Your angular size is 0.1 degrees, and then you're going to times it by 2 pi times your distance. Now 133 million is going to be... you're going to have to put that in your calculator. Gosh, I keep doing that. I don't know why I want to put 133 million divided by 360 degrees. So you're going to use that same formula for physical size, and that's going to be your true size. So in your calculator, actually, I'm just going to hit return and put my last calculation in there because I like to do that. Because I already have everything other than I need to change my physical size or my angular size to 0.1 degree. And then I have 2 pi. And then I'm going to have 133,000,000. All right, and that's going to be 232,128.8. And that's going to be kilometers. Now, in your problems online, you might have to change that to, I'm kind of out of time, change it to scientific notation. So if I move 1, 2, 3, 4, 5 to right there, it's 2.32 times 10 to the 5th power kilometers. And that's what you're going to have in your homework problem, just like that. All right, Well, we're going to move on to part 3 here in a few minutes, so stay tuned for the next video.